by the end of this lesson, I'll be able to graph quadratic functions in the form of y equals ax squared and y equals ax squared plus c. The essential question is, how does the leading coefficient a affect the shape and position of the graph? And we talked about a quadratic already. Remember, you have to have an exponent of the degree 2. That must be your highest to be quadratic. And remember, the graph of a quadratic is always a U-shaped figure. Either it's a U-shape or an upside down U. A few people, when they were graphing, they were making V's. So remember, you have to round it out. You don't want to just make a V going straight to a point. It has to be rounded. It's a U shape. It's a U-looking shape. It's round. It doesn't have any straight lines or sharp edges. The parent function of the quadratic function is f of x is equal to x squared, or you might see it as y equals x squared. All right? And remember, every single quadratic is just a transformation of the parent function. So that means it's whether it's a translation, a stretch, a shrink, a reflection, it's just a transformation of the parent function. Right? So it's like it could go like that, like that, like that, like that. It could even reflect. That would be a stretch, and that would be a shrink. All right. All right, and that's what we're talking about right now. Graphing f of x is equal to ax squared when a is greater than 0. Notice, this is when a is, the blue graph is when a is equal to 1. So when a is between 0 and -1, it's going to get a lot wider. When a is less than -1, that means like -2, -3, -4, -5, -100, -1,000, it's going to get a lot skinnier. So this is another illustration. Anytime you're between 0 and 1, that means your leading coefficient is between 0 and 1, it's going to get really wide. When you're between 0 and -1, you're going to get wide. The closer you are to 0, the wider you will get. Okay? If it's 0, remember, it's not a parabola. So as you approach 0, the closer you get to 0, the wider it will get. Now, the further away you are from 1, going to your right, it's going to be really skinny. And then the further away you are from -1, it's going to get really skinny. So remember, wide, skinny, skinny. And we're talking about our leading coefficient A. Remember, wide when you get closer and closer to 0, skinny as you move away from 1. You're getting really large numbers like anywhere from 2, 3, 4 to 1,000. And then when you go -2, -3, -4 to -1,000, it's just going to keep getting wider and wider. All right? And when A, this is when we're talking about A. As A increases, do you see how it's getting skinnier and skinnier? This keeps getting skinnier. As I go and make A closer to 0, it's going to keep getting wider and wider. It's going to keep getting wider. Wider, 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 wider. It keeps going. Now it's going to get really wide. It's getting really wide. And then once it gets to a negative, see how wide it's getting? Once it gets to negative, it reflects. And it keeps reflecting like so. All right, so do you guys see it? So when it's negative, and as I go further to my left, like -2, -3, -4, it's getting skinnier and skinnier and skinnier. Cool. So again, now it's getting wider and wider, wider as I get closer and closer to 0. It keeps getting wider and wider as I get closer to 0. And it's super close to 0, and then it's going to reflect the other way. And it's still wide, and then it's still wide, and then it's getting skinnier, 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 skinnier. All right? All right, so let's take a look at C. So C, you see it's making a shift up and down. So now it's going down because that's at -2.5. That's going to be at -2.5. If it's at -2, the vertex is at -2. if C is -1, the vertex is -1. And then if C is 1, the vertex 1. C is, we'll make C 8 of it. And the vertex is at 8. What happened to this graph versus its parent graph? All right, so let's take a look at that. What's happening to this graph versus its parent graph? So the first thing, that's the parent graph in green. And that's how it looks. So the first thing I can see is that it's reflected. All right, so that negative right there is telling me I have to reflect it. Then what happened? There was a vertical shift up. All right, so that +9 is telling me I have to shift it up. Secondly, even when I shift it up, they are not mapped onto each other perfectly. So that means that 4 means it's getting skinnier. And that 4 made it slim down. Cool? And let's take a look at the other do now question. Okay, so first, this is our parent graph, and the first thing I can see is that there's a vertical shift down. So I have to shift it down. -10 is telling me to shift it down. Then the 1/4 is telling me that's what makes it wider. The 1/4 is making it wider. All right? And that's what happens. All right? So it says order the group of quadratic functions from widest to narrowest. So here's our numbers, and who thinks they know which one would be the widest? Remember, the closer you are to 0, the wider you're going to be, regardless of which side you are, whether it's negative or positive. The smaller the number, so when we're talking about the width of a parabola, don't worry about the negative sign. Just worry about the absolute value of the A term. Ah, you got it, Julian. So this one would be number 1. Okay? Which one would be number 2? A. Perfect. Thank you, Michael. So A is the next one. Which one comes after that one? Oh, I saw you had it, Julian, because you had the 2 different letters. Sorry. Yep, that's number 3. And then which one? You got it. So then this one's number 4, and the last one, this one has to be number 5. And basically all we're doing is writing the decimals, and we know that a half is 0.5. We know that's 3. We know that this is 0.25. 5 divided by 8, we know is 0.625, and then that's 4. So this one is the smallest, then it's this one, 0.5, then it's 0.625, then it's 3, and then it's 4. The smaller the number is, the absolute value, the smaller the number is, the wider it will be. That's it. That's the lesson for today.